Okay, we're going to continue with complex numbers. The first part, I'm going to talk about the fundamental theorem of algebra, which states if a polynomial has a degree of n, then it has exactly n zeros, including the multiple zeros and the imaginary zeros. So you can look at the highest exponent to tell how many zeros or roots that the polynomial will have. So for example, if I have a polynomial here, x to the third plus 3x minus 5, this has 3 zeros because it's a third degree polynomial. If I have x squared plus 2, this has 2 zeros. X to the fifth minus 8 has 5 zeros. Doesn't matter the number of terms, you're looking at the degree, which is the highest exponent. Now that's including multiple zeros, which means if positive 2 comes up twice, that's a multiplicity, and that's a multiple zero. So it's including multiple zeros and imaginary zeros, which are the zeros that contain I. The complex conjugate zero theorem. If a polynomial p of x has real coefficients, then its imaginary zeros appear as conjugate pairs, meaning if a plus bi is a zero, then its conjugate, a minus bi, also has to be a zero. So if you have a polynomial p of x has a zero of 3 plus 2i, then you know another zero is 3 minus 2i. And so if I'm trying to find the zeros of this polynomial, you can first check to factor, but notice nothing's going to multiply to be positive 13. That adds to negative 4. So what I'm going to resort to then would be to use the quadratic formula. X equals negative b plus or minus the square root b squared minus 4 times a times c all over 2a. So my b is negative 4, so that's going to be negative 4, or the opposite of 4, plus or minus the square root of negative 4 squared minus 4 times 1 times 13 all over 2 times 1. So that's going to be positive 4 plus or minus the square root of 16. This is the important part here. This stays a minus, and that's going to be 52 all over 2. So 4 plus or minus the square root of negative 36 over 2. Well, negative 36 can simplify to 6i. And then to simplify, because the whole binomial is being divided by 2, it means each part is being divided by 2. So that's going to become 2 plus or minus 3i. And understand that this is 2 zeros. It's 2 plus 3i, but its conjugate also appears 2 minus 3i. This was a quadratic. Okay, so there was 2 zeros, and these are the 2 zeros. Okay, so I'm going to write the quadratic with the 0 x equals I. Well, if x equals I is a 0, then x equals negative I is a 0 as well. Okay? And to write the quadratic, I first have to write it in factored form. Understand, when we're finding zeros from factored form, what we did was set each of them equal to 0 and solve. Right? So to write it in factored form, if I was going from here back to factored form, I would do x minus the 0. So x minus negative 2, x minus 5. Well, x minus negative 2 becomes plus, and that goes back to the factored form. So what I'm going to do here, I'm going to erase this. What I'm going to do here is first write it in factored form. X minus I times x minus negative I, well, that's going to become x plus I. So x minus I times x plus I. And then to write the polynomial, I'm going to multiply them out. Well, x times x is x squared. That becomes plus I x. This is minus I x. And then this becomes negative I squared. Well, the 2 in the middle, positive ix, negative ix, will cancel out. And notice that this is a difference of squares. So that will happen with the difference of squares. So I'm left with x squared minus, and that I squared becomes negative 1, so that becomes x squared plus 1. This one's a little bit trickier because the 0, or it could be called the root, is a binomial, 1 plus I, and then I have 1 minus I, because its conjugate is also going to be a 0. Now, I didn't mention this in the other one, but because it's a quadratic, I know there's only 2 zeros, or 2 roots. And what I'm going to do here is I'm going to do same thing, x minus the 0. 1 plus I times x minus the 0, 1 minus I. Let me put brackets around these. Whenever you do 2 parentheses, you really should make the outer ones brackets, so let me go ahead and do that. And this can be kind of treacherous, but I'm going to show you a way that if you know your difference of squares, it can make it a lot easier. Okay? Well, first, let's distribute that negative, so it's going to be minus 1 minus I, and then x minus 1 plus I. And what I'm going to do now is I'm going to group the x minus 1s and think of that as one item. And you can use, and if you notice here, this is going to be that difference of squares, because the a is my x minus 1, my b is the I. So I have x minus 1 minus I and x minus 1 plus I, and it's going to end up being that difference of squares. So when I go ahead and simplify this, remember, this is just going to be a squared minus b squared. So that's going to become x minus 1 squared minus I squared. And I can square x minus 1, that becomes x squared minus 2x plus 1, and then minus negative 1, so I have x squared minus 2x plus 1 plus 1, so that's going to be x squared minus 2x plus 2. Okay, here's two for you to try. Writing just again the quadratic. So there's 2 zeros for each, with the zeros given. All right. Why wouldn't the shrimp share his treasure? Because he was a little shellfish.